Okay, welcome back. Today we'll be studying about lenses, that is in the physics part of grade 11 science. Now before I start, I'll give you a short introduction about what is this lenses is about. Now, if you take lenses, you would have seen this in our normal day-to-day life. Now the people who are using spectacles, even they have lenses. Okay. Now what happens to these lenses? Now consider there is a lens, and first point I have said that there is a refraction. That means what happens is when a light ray passes through this lens, say a light ray is passing, there is a refraction in the ray. That means there is a small change in the ray. It will not go directly. There's a small change. Okay, we'll study further when we come to the uh, lens part. And second point, I have said that there is a lens in the eye. In our eye also there is a small lens. Okay, and the third part, the uses. Now the uses of these lenses are used in microscope, magnifying glass, and also in the simple microscope. Now this you would have seen at your home. Magnifying glass, you would have used this lens, and by just looking at the magnifying glass you can say that there is a lens. Okay, now you know the two types of lens. We will be studying about convex and concave lens. This is called planar because there is only one lens on one side, and these are called biconvex and biconcave because there is lens on both sides. Okay, is that part clear? Now let us move on to the first type of lens, that is convex lens. Now how is a convex lens formed? That is, it looks like we take two spheres. Take two spheres and then keep like this as overlap. Okay, when this is overlapped, now this part you take it as the convex lens. Understand? Okay. Now if this is the convex lens means now there is two centers. Now if you join these two centers, this line you call it as the principal axis. You call this as the principal axis, and there is a center of this lens. If you consider this lens, there is a center. You call this as the optical center. Okay, now consider the lens. This is the way we draw diagrams. Now what we are going to do is, on the further we'll be studying what are the images you get when you place an object. Now before that you should know what are the rays available for this convex lens. Now if you take the lens and say, for an example, a ray passes through this lens. Now all rays that comes parallel, now this is the principal axis. Okay, all rays that come parallel to the principal axis always go through a certain point. Any ray coming parallel to the principal axis, it go through a certain point. Now this point you call this as the focus, the focal point. Okay, I'll call it the focal point. And the length, now normally we mark it with capital F. Okay, and the length from the lens, now here is the optical center. From this is where the lens is placed. From this to the focal point, you call this as the focal length. Okay, is that part clear? These are the terms you should understand. Focal length, and we mark it using simple F. Okay, and this is one type of ray. The next is, now the ones which go parallel go through a certain point. I told you that it is the focal point. And the rays, now it is like the opposite. And the rays, now rays can pass through two sides. Even from this side it can travel, and even from this side it can travel. Therefore when marking the focus, when you mark F, there are focal points on both sides of the lens. Understand? So this side also you have an F marked. Okay, is that clear? Okay, now say another ray that comes, that goes through F. So what will happen to this? The ones which goes through F will go parallel to the principal axis. Okay, that is the second part. The ones which go through F will go through parallel to the principal axis. Is that part clear? Okay. The third one is any ray that is going through the optical center, there will be no refraction in it. Say, take for an example, a ray coming this way. It is through the optical center. So there will be no change in the ray, and it will just go through the same point. These are some examples. Now you need to understand all these three types of rays in order to construct diagrams. Diagrams in the sense we are going to place the object in certain places and check where we get the image and the properties of images. Now let us move on to the first part. Now all these are convex lens. First part is that now here let me show you how to draw this diagram. Say the lens is placed here. This is the principal axis. This is the optical center, the principal line. This is F and this is F. Also I have marked another point. We take this as 2F. That means it is twice the focal point. We need this also. Okay, so you have F, F, 2F and 2F on either sides. Okay, now the first part is what happens when you place, when you place an object between the lens and the focal point. So I place somewhere here. This is my object. Now what are the rays I can draw? One is that the one which goes parallel will go through the point F. And the other is, you can say that the one which goes through the optical center, there will be no change. Now if you extend these rays, will they meet? No, they will not meet because they are going away. So what we do here is we extend these lines towards the other side. We extend it this way. Okay, is that clear? Okay, we extend and check where these two rays meet. It meets somewhere here. This is where the object is formed. This is the object, this is image. This is where the image is formed. Now you have few properties of the image formed. One is that it is magnified. It is magnified, isn't it? Yes. The second is it is virtual. Virtual means you cannot take the image onto a slide. Understand? If the image forms on the other side of the lens, then you can call it real. Now here you have to say that it is virtual. Okay, and it is upright. Upright. Now if you take this as the head, it is not upside down, it is just upright. Is that correct? Okay. Now let us move on to the second part. That is what happens to an object when placed at the focal point. Now let us place an object here. And let us first draw the ray diagrams. First you can take the first ray diagram, that is if one is parallel, it should go through F, that is 1. And what is the next part? The one which goes through the optical center should go as it is. Okay, now what can you say about this diagram? Okay, when we place at F, what happens to the image? Now this is the object, the image. The image, these lines do not meet. Even if you extend this side or whatever the side, these lines do not meet. They go parallel to each other. Therefore we call that the image is formed at infinity. One is that it forms at infinity. Also remember this point, the image is magnified. These are the 2 points. Okay, is that clear? Okay, and then let us move on to the next part. That is what happens when you place an image between focal point and 2F. First let me mark all this. There should be okay. Okay, now what are we going to do? Where are we going to place the object? The object should be placed between focal point and twice the focal point, somewhere here. You can place it anywhere between the focal point and twice the focal point. Now you have to draw the ray diagrams. That is, you can draw one as parallel, that should go through F, That is one diagram. At least you need how many? You need two. What is the next type? Yes, you can draw the ones which go through the optical center. Let me extend this. The ones going through the optical center. Okay. Now what has happened here? Now look here. This is where the lines, the rays are meeting. So this is where the image is formed. Okay. Now the image is formed on the other side. So you can say it is real. Okay. Is that part clear? Okay. The other is that it is magnified. And one more important point, you can say that it is, yes, upside down, right? So you can say it is inverted. Is that clear? Okay. And then let us move on to the next part. What happens to the image formed when you place an object on 2F? This is the object, this is the image. Okay, let us place at 2F. Let us draw the diagrams first. First you have to draw the parallel one. So if you draw the parallel line, it goes through F. Okay, one is completed. And next let us move on to the next ray. That is the ones which goes through the optical center will go through the same point and see where the image is formed. If you draw a proper diagram, the image will be formed at the same point. If you keep it at 2F, the image also will be formed at 2F on the other side. So what are the properties? One is that you can say it has the same size. And one special point is that it is inverted. Okay, also you can say it is real. Okay, just know these characteristics. Okay, even if for the exam, if they ask you these diagrams, quickly you can take a piece of paper and then draw these diagrams and check where you get the images. Okay, and then let us move the next part. What happens to the object placed at beyond 2F? Now let us draw these. And then okay, beyond 2F. So I place somewhere here. First let me draw the diagram. And what is the other ray diagram I can get? Yes. So where is the image forming? Somewhere here. This diagram is somewhat similar to the one which is placed between focal length and twice the focal point. Where is it formed? Beyond 2F, right? The same thing, it is just the opposite. When you place it away beyond 2F, the image formed is between F and 2F. Observe, the image formed is between F and 2F. Okay, so what are the properties? One is that you can say it is real. In the earlier diagram it was magnified, here it is diminished. It is smaller, diminished. And what is the other part? It is formed between F and 2F, diminished, okay, real, and inverted. Okay, you can say it is inverted. Is that part clear? Okay. And the last part. What happens to the image formed when an object is placed at infinity? Now the rays coming through infinity, you have to take them like they come from F. Okay, this is one type of ray we have studied. The ones which come through F. The ones which come through F will go parallel to the principal axis. That is clear, right? Okay. Now from parallel, if we consider these rays, they should come parallel. Therefore, the next ray I am going to draw should be parallel to this. And also the other requirement is it should be what? Yes, it should go through the optical center. So if I draw a parallel line, okay, it looks this way. So where is the image formed? The image is formed here. Is that part clear? Okay, so you can say what are the properties. So it is just the opposite of the image placed at infinity. Understand? It is just the opposite. So you can say it is diminished, and also it is real. Okay, real, diminished, Okay, is that part clear? Okay. Now these are the diagrams you have for convex lens. And now let us see what we can do with concave lens. Okay, now when you consider concave lens, here, now since we had so much of diagrams for convex lens, but for concave lens you have only one diagram. That is, wherever you place the object, always the image will be formed only at one place. Okay, let us try one. I'll just show it using one example. I'm going to place the image, the object at a point somewhere here. First, what should I do? Okay, you should, before drawing, you should know the ray diagrams for concave lens. Now you cannot use the same rays for the ones you use for convex lens to this concave lens. Is that clear? You cannot use the same ones. So here what happens is that you have the principal axis. Okay, here let us say you have F, focal point is here, this is twice the focal length, this is twice the focal length. Okay, now here when a ray goes parallel, it will not go through F. There is a small change. The change is that when it comes here, now since this is concave lens, it expands, okay, diverges. Okay, so here when it passes through the lens, it goes as if it is coming from F. Is that part clear? It goes as it is coming from F. Okay, are you clear with that part? And the next part is you can use the same one we used earlier, that is the ones which goes through the optical center will go as it is. You have to understand this. Are you clear with that part? Okay, so let us draw the ray diagram for this. Okay, the first one, first I can draw that the one which goes parallel. So the one which goes parallel will go as if it is coming from F. Something like this. Okay, and what is the next one? Yes, you can draw this, the one which goes through the optical center. Now where is the image formed? The image is formed where these two lines meet. So this is the only possible place. Understand, it is formed on the same side. So we can write the characteristics. One is that it is diminished. And the other is it is virtual, and also you can say it is upright. Is this part clear? Okay, now wherever you place the object, you will get the same diagram. Okay, if you can just try it, placing here anywhere you want. Okay, is that clear? That's all you have under lens. And thank you for watching, and for further videos subscribe our channel, and thank you for watching.